all these things. There we go. So we're going to start off with number 10 on the review. And like I said, position, velocity, acceleration, all connected with each other, right? You do the derivative, it works its way down from position, down to velocity, down to acceleration if you do the derivative. And then if you do the antiderivative or the integral, you can work your way backwards, right? Velocity is equal to the integral of an acceleration function plus c, and the position function is equal to the velocity function plus c. All right, so something similar to this. Let me take a look here. Let's say we're given, right, that the acceleration function is equal to sine of 2t, right? And the velocity at the start is equal to 6, and the position at the start is equal to -5. Write an equation for the position function. S of t. All right, write an equation for the position function S of t. So knowing that I have the acceleration, we just have to work your way through it, right? So it goes this way. We have to find, with the acceleration function, if I take the integral of that, I'll end up with the velocity function. And if I take the integral of that, that's the integral sign, by the way. Hopefully you guys see that it's not just an S, right? We'll end up with the position function, right? Maybe I'll write that out because that's going to look confusing. The integral, right? And then do the integral again. So go ahead and do this right here. The first one up, to go from acceleration to velocity, I know that velocity is going to equal to the integral of the acceleration function dt, which means that that's going to equal to the integral of sine of 2t dt. The integral of sine is not cosine, right? That's the derivative of sine. The integral of sine is actually negative cosine, right? Did I do that correctly? The other thing that you need to be careful with these problems is that, yes, it's true that the integral of sine of u du is equal to negative cosine of u plus c. But please be careful, that stuff inside there needs to actually be equal to just a single thing. If it's equal to 2t, that gets affected by the chain rule. So always remember to be chaining, right? Always remember to be using u substitution and pay attention to the chain rule if there is one that needs to be applied here. So I'm going to go ahead and do that chain rule right here in blue real quick and let u equal to 2t, du is equal to 2 dt, which means that du over 2 is equal to dt. So I'm going to go ahead and replace that right there. I'm going to have here the integral of sine of u times du over 2. So when you integrate this, I end up getting here my new velocity function is going to be equal to negative cosine. I'm going to take that 1/2 out front. You guys okay if I shortcut this? I'll show my work. This is 1/2 times the integral of sine of u du, which is going to equal to 1/2 times negative cosine of u plus c, which is going to equal to negative 1/2 cosine of u, which in this case was 2t plus c. This, of course, is equal to v of t. You're not done, right? Once you get to there and you find out what the velocity is, this is not actually the final velocity function. This is a general velocity function, not a particular one. I don't have this plus c yet. So I got to figure out what that plus c is. They tell us that when t is equal to 0, the velocity is equal to 6. So when I plug in 0 here, I'm going to go here and evaluate it for 0, 6. I'm going to plug those values in. I'll have here 6 is equal to negative 1/2 times cosine of 2t plus c. Cosine of, knock me, we're plugging in a 0 there for t. So I end up with cosine of 0. Cosine of 0 is negative 1. I'm sorry, what the heck are you saying, knock me? Get it together. Cosine of 0 is 1, multiplied by negative 1/2. You're going to end up with 6 is equal to negative 1/2 times 1, which is a negative 1/2, plus c. Add the 1/2 to the other side. You can write this as 6.5 if you want, or as a fraction, which would come out to be 13 over 2. However you want to write it. Both are perfectly valid. Now that I have that c value, my velocity function can be written out like so. It can be written out as v of t is equal to negative 1/2 cosine of 2t plus, how do you guys want to write this? As a decimal or as a fraction? What do you guys prefer? Fraction? I like fractions. 13 over 2. That's probably how you're going to see it on the test. But yeah, just keep that in mind. Multiple choice questions, they tend to liken them as fractions. I don't know why. But you're still not done. I only have the velocity. That means I got to keep going there. And to get over here, I need to now figure out the position function. I'm going to work that off over here. The position function is going to be equal to the integral of negative 1/2 cosine of 2t plus 13 over 2 dt. I'm going to work on this one right over here. So remember, the position function is just equal to the integral of the velocity function. That's all I did there. I just took the velocity function and I plugged it into this integral to help me find out what this one's going to be. So do this right here. Hopefully, I'm gonna go ahead and rewrite this as negative the integral negative 1/2 of the integral of cosine of 2t dt plus the integral of 13 over 2 dt. Use substitution again, right? Chain rule this. I hope you guys are okay with this. I'm going to do this chain rule in my head real quickly because I just remember this from the other one. I'm going to have here negative 1/2 times, this is going to be another 1/2, right? The integral of cosine is going to be sine of 2t, right? That's going to be this one right here. This is going to be plus 13 over 2 times t plus c. Cleaning this up, this is going to come out to be, this position function is going to come out to be negative 1/4 sine of 2t plus 13 over 2 t plus c. Again, this is just the general solution. If you've come this far, you've done quite a bit of work, right? If this was a 5-point problem, I'd say you're pretty much at 3.5 points, almost 4 points. I'd give you 4 points if you get to this point. Yeah, I'd give you 4 points out of 5 if you get to here. Yeah, 4 points out of 5 if you get to here. It's a lot of work here. The last part, though, of course, is we got to evaluate this and find out what the c is. The position function tells us that when time is equal to 0, it's starting at an initial position of -5. That's that right there. We go ahead and plug in these values, and we see that -5 is equal to negative 1/4 sine of 2 times 0 plus 13 over 2 times 0 plus c. Sine of 0 is 0, so this goes away. 13 over 2 times 0 is 0. That goes away. We get a constant of c is equal to -5. And we just plug that into our final equation. And that's a 5, knocking that's not. S of t, our position function, is going to be equal to negative 1/4 sine of 2t plus 13 over 2 times t plus c, which is going to be -5. And that is my answer. That is my answer. So that's all the work right there to get to that final answer for this problem. Number 10 on your study guide is pretty much the same thing, but you need to practice your integrals and take the integral of what is it that they have there? It's an e function, e to the 2t, right? So you just practice doing your integrals for that one. And yeah, that's that right there. I'm going to go back over there and let's take a look at what were the other polls that we had besides from number 10. Looks like number 12A is one that we're going to have to take a look at, and along with 13A and 11. I'll reopen up the polls after we do a couple more, and then we'll see how you guys are feeling from there. Aside from that, though, I'm going to pause every now and then and ask if you guys have a question as I'm doing these. I really suggest you ask questions if you have any questions. This is the time to ask them. I can't tell if you get them or not, you know? If no one says anything, I just assume that you're all smart and you get them, which is not a good thing to assume. Not everybody understands it, but you know, if you don't ask questions, I don't know what to answer because in my eyes, I don't know where to start. I'll just end up explaining everything. That's up to you guys. All right. Let's see here. Monstrosity of a problem, Brian. Yeah, but is it? I call these types of problems like they're tedious more than anything, right? Because you're doing the same thing twice, right? You do the integral, find out what c is. Oh, hey, look at this new function. Do the integral again, find out what c is. Oh, you're done, right? And it's annoying, but you got to practice your integrals, and this is one of those problems where they're just testing you how well you can do your integrals, how well can you do your u substitutions, how well can you find your c. Not a question, but hey, juniors, I'm running for class vice president and would really appreciate if you guys vote for me on May 3rd. Yeah, you got my backing on that, Monica. Juniors, go vote for Monica. Class vice president. Who's running for class president? Max, you're running too? What are you running for? Are you running for vice president as well? Or are you running for president? Why is none of my students running for president? Oh, you're just kidding. I mean, why not, Max? Where do I vote? That's a good question. Monica, where do they vote? Are they going to be given a link to vote online? And also, when is May 3rd? May 3rd is a Monday. You get an email link next Monday. All right. And then David, I haven't seen a plug like this since t equals 5 in v of t. Oh, David. All right. I'm just going to move on. Let's go to the next one, which is going to be number 12A was the next highest vote. So let's take a look at 12A, shall we? Since we have no questions over here. 12A is asking us to plot a slope field for the given differential equation on the indicated points. By the way, you do not have to do every single point. You just have to do the points that you can see. So I don't have to do 2, 0. I don't have to do 2, 0, 2. I have to do the ones that I have a dot on. So I'm going to go ahead and I'm going to copy this right now because I don't want to redraw this one. Let me go ahead and copy this one. This is going to be something like number 12, right? Something like number 12 right here. And we're going to go ahead and paste that onto there. And let's get a different differential equation for us to practice doing this, right? So slope fields are one of the easier things to do, but the weirder topics to cover because it's just a little weird. I'll be honest with you. There's no real like other way for me putting it other than the fact that it's weird. Give me a second here. Let me take a look here. Let's take a look at one problem that's similar to it. Excuse me. So the one that you have was x times y minus 1 quantity squared. We're going to go with the differential equation dy dx is equal to, let's go with what's a good one? Let's go with 2x times 1 minus y. Let's go with that. Let's go with that one right there. So all you have to do to create your slope field is you pick a point that you want to start off with. Let's start off with this point right here. This point right here is going to be the point 2, 1. Right? That's your x value. That's your y value. You plug it into the slope field. The differential equation they give you, and at that point, the slope, the derivative at that point, the derivative value, which is the slope of the tangent line at that point, is going to be equal to 2 times 2 times 1 minus 1, right? All I'm doing is plugging it into this equation up here, into this differential equation. I'm just plugging in my x and y values, right? This is my x value. It gets plugged in wherever x is. And this is my y value. It gets plugged in wherever y is. And then I just simplify it and evaluate this. So this is going to give me dy dx is equal to 2 times 2, which is 4. 4 times 0 is 0. What does the slope look like for a what does the slope look like when the value is 0? I'm hoping you guys remember a slope of 0 is just a horizontal line, right? So you kind of have to know these values, right? If your slope is equal to 0, it's kind of flat. If your slope is equal to a positive number, it's kind of like this, right? This is something where the slope is equal to 1, right? If the slope is equal to -1, it looks something like that, right? And then I think one major question I always got for these slope field problems is like, well, knock me, I know that +1 looks like this. How should I draw the slope equaling to +2 then? And what I tend to do is, if you want to, you could count the dots. You could go up 2 and then over 1, and then you kind of like make it a little bit higher. But in reality, all that the AP exams are really looking for is that you understand that the slope of 2 is just a little bit steeper than 1. Okay? And the slope of -2 is going to be a little bit steeper in the negative direction. How much steeper? Just a little bit more steeper. And you'll say, but Nagmi, what if the one of the problems is going to be -3? Right? How steep should I make that? Just make that steeper than that one. Well, then how does that look any different from -10? And I'm going to just stop you right there from snowballing into like panic mode. It just has to be relatively steeper than what you have drawn. So if you have one that's a slope of 1, and then you have another slope that's a slope of 3, just make your 3 look a little steeper than the other one. It doesn't have to be like, they're not going to take out a protractor and a compass and just measure like, this kid didn't actually get the right steepness of this, take a point off, right? They just have to see that you understand that, okay, this slope over here is steeper than the slope next to it. So we're going to make it a little bit like so. If some of you are still lost, let's actually just do another problem here. Let's take a look at another point. Let's start with these 3 points right here. Let's go with x equals to 1, y equals to 2. Plug that into this derivative right here, or I'm sorry, this differential equation, dy dx. And that's going to equal to 2 times 1 times 1 minus 2. Again, right, because my x value goes in for this x value, and my y value goes in for that y value. And you just evaluate it. This one right here is going to come out to be equal to 2 times 2, which is 2. 2 times -1 is going to give me -2. So at this point right here, it needs to have a slope of -2, which means it should go down 2 and over 1. It's going to look something like that. See that? That's my -2 slope right there. Because at that point, I have my slope is equal to -2. And we do this for all of them, right? And we do another one. This point right here is 1, 0. Plug that in. dy dx is equal to 2 times 1 times. Knock me, you messed up. That's not 1, 1. Did anyone see that I messed up there? You guys just let me just mess up like that on that one. Did anyone see what I did? I messed up big time on this dot right here. This is not 1, 2. What's that point right there? Anyone? That's a terrible mix up. That's 1, 1. Knock me. That's 1, 1. How did you guys let me write that down? Huh, I see a pattern here. When y is equal to 1, this is always going to equal to 0. So I can just pretty much say that all these right here are going to equal to 0, aren't they? Bam. I knew it. Max, if you knew it, why'd you let me do that? Just let me make that mistake the whole way through? It's hurtful, man. It's hurtful. All right, let's keep going over here. This will be 2 times 1, which is going to give me, well, that's just going to give me 2. So here I have a slope of 2. Up 2 over 1. That one's going to look a little bit steeper than a 1, so it's going to go something like that. There we go. And then you go through and you plug in and you just do it for all of them, right? 0, 0 would probably be an easy one. 0, 0 is going to give me a flat line right here. 0, -1 is also going to give me another flat one right here because I have a 0 in there that multiplies with them. And you just plug in all the rest of them. You know, this is going to be a negative and a 0, so that's going to be a -2. So it'll be something like that. That's not bad. Yeah, that's not bad. And then you kind of just graph the rest of them along the way. Any questions on slope fields? Are you guys okay with them? Does it seem like it's a little too much? That's all this is. This would be 1 and -2. That'd be very steep. I think this would be steeper. No, the -1 again becomes +1. It becomes like a. What would this one be? 1, 0 would give me 2. 1, -1. Let's do that real quick. 1, -1. I just out of curiosity. What would 1, -1 be? This would be 2 times 1. 1 minus -1, which would be 2 times 2, which would be 4. This would be a slope of 4. That's even steeper. This actually leads. Wait, is it -4? And Max, yes, there are AP Calc videos for slope field if you want to go check them out. But I believe this one is going to be +4, Monica. I think it's going to be positive. Am I messing that up? Because it's 1 minus -1. Isn't that going to give me a +2? Am I messing this up? Am I messing this up? I plug in 1 here. plug in -1 here. That's going to be this dot right there, right? That's 1, -1. That's this dot right here. No, my bad. Okay, so it is 4. So this leads to my point right here. You see how this dot right here is a slope of 2. This one over here should give me a slope of 4. If I draw my slope here like this, because I know it's positive, that's going to be marked wrong. That's going to be marked wrong because I know that I drew this one up here as a slope of 2. This one needs to be steeper. It needs to be a slope of 4. So I need to make it a little bit steeper. How much steeper? It doesn't have, -4 on the other one. Thank you, Monica. We might as well just fill this out completely. And that's what I'm trying to say here. It just has to be a little bit steeper. Does that look like it's a -4 compared to that -2? I don't know. I don't actually know if that's exactly -4, but I've shown that these ones are steeper than these ones, right? That's kind of what they're looking for when you're doing these slope fields on the AP exam. And yeah, that's pretty much all you have to do when you're calculating these slope fields. You just pick a point, you plug in the x and y into your differential, you're going to get a number out. And what that number is depends on how you draw your tangent lines, right? You're drawing your tangent lines as just segments, just little tangent line segments. So technically, this tangent line would have gone on forever, but we're just drawing for like a little part of it here, a little part of it there, right? And that's it. That's all a slope field does. Okay, hopefully that answers your question. I'm hoping. I hope. Yeah, I hope that does. If not, type into the chat. Let me know. I'm going to keep going here. Because the next one up that I saw that required some help was number 11. And then we'll go on to number 13A. So let's go look at number 11. What type of question was number 11? Knock me. I don't know. I'm going to go look. Consider the differential equation here. Given that f of 0 is equal to 1/2, find the equation for y equals to f of x. So here's the differential equation, right? Again, just like the slope fields, if you plug in x and y, you can calculate what the slopes are. But in this particular case, they're asking us to solve for y, given a dy and a dx, right? Given this differential. And we know that if you take the integral of dy, we can get y equals 2, right? So again, I'm not going to do this one exactly. I'm going to find one that's similar to it, and we're going to go ahead and solve that differential equation instead. Do you guys need to see one with the e function? Is that what it is, or is it just the way that it's worded? Let's do one with a sine function instead of an exponential. Or do you guys want to see one with the e function? Yes, e function? Okay, I can make one up with an e function. Let's do that then. Give me 1 second, because I won't have a c value that goes into it. E to the x squared. Okay, I guess we can kill 2 birds with 1 stone, because e to the x squared is your number 1 problem up there. Ooh. Oh, that's going to be a little rough. It's going to be a little rough. Let me see here. All right, let's say I have a differential equation. This is like number 11. And this differential equation is going to be dy dx is equal to 2x over e to the, if we do y squared, it's going to be a little too much because we don't have a y down there, but let's do it. Let's do it like this then. Y squared times y. Yeah, let's write that again. So I'm going to write this out as y times e to the y squared. There we go. We'll go with that one. We'll go with that one. So here's our differential equation, right? Give me 1 second so I can get an initial condition that actually works nice. Because, again, I'm just making this up. I need to make sure that it goes through a point. Give me 1 second. Let me find a point that works. That comes out nice, I should say. Let's go 2x divided by y times e to the y squared. that supposedly works, and it looks like it has a, let's get a nicer point, right? Yeah, there we go. We got it. Here we go. The initial condition is going to be, we're going to be asked to find y is equal to f of x, given that f of 0 is equal to 1. There we go. Let's take a look at this one, right? I'm telling you right now, you'd love to see differential problems on the AP exam. You should love to see them on the free response section. Easiest point you can earn is by getting everything that has a y on one side and everything that has an x on the other side. That's the first step for solving differential equations. If you start to see like like you see these differentials and they ask you to find y, you should instantly think separate the variables. So I'm going to cross multiply this over. I'm going to end up with y e to the y squared dy is equal to, and then cross multiply the dx over 2x dx. And what I'm hoping it comes to your mind is when you see these differentials and they ask you to find y, I'm hoping that you're thinking to yourself antiderivative, integral, right? Integrals, because when you do the integral of a dy dx, it should go back to just a y, right? Just like back when you first learned derivatives, I'm hoping you remember when you learned derivatives, or they give you a function y and they say, hey, I need you to find dy dx or y prime, your mind should automatically go, I need to find a derivative, right? And I need your brain to work both ways on this one, right? So y related to dy dx, you take the derivative to get to there. If they're giving you dy dx and they want you to find y, I need you to realize that's an integral problem or an antiderivative, go backwards. So back and forth, right? Derivatives, antiderivatives. Okay, so I get to here. I'm going to go ahead and take the integral of both sides, which you are allowed to do on these differential equations. Right here, right? And we're going to go ahead and integrate these two. Now, integrating your function on the left, it's going to require some u substitution, right? Because this is not as clean as it's going to be, because you know the integral of e to the u du is just equal to e to the u plus c. That's all well and good, but that's y squared right there. So I need to replace that with u. So I'm going to go ahead and let y equal, nope, knock me, we call that u. Let u equal to y squared, which means that du is going to equal to 2y dy, which then means that du over 2y is equal to dy. So now I can replace these things right up here. I'm going to write this as the integral of y times e to the u times du over 2y. And the two y's right, the y right here and the y right there is going to cancel out. This, of course, is all still being equal to this guy over here, which is the integral of 2x dx. Actually, I could have just done that integral because I think you guys know what the integral of 2x is. I'll do it right now. So this will be 1/2, right, times the integral, because that 1/2 is under the du right there. E to the u du is equal to the integral of 2x dx. Dang it, knock me. You said you were going to do that integral. I'll just do that integral right now. Integral of 2x, you don't need to do any u substitution. Hopefully you guys see the power rule. This will be x squared over 2, and the 2 right there will cancel with that 2 on the bottom. This will just become x squared plus c, right? Over here on the other side, we're going to go ahead and finish this off. This will be 1/2 e to the u plus, I mean, this is e to the u, isn't it? This is equal to x squared plus c, but of course u was equal to y squared, so I end up with 1/2 e to the y squared is equal to x squared plus c. At this point, this is where you need to ask yourself, do you want to solve for c now or do you want to solve for c later? And it doesn't really matter. I prefer solving for c right now. It's less algebra you have to do for solving for c. If you solve for y and then go for it, it gets a little messy. But I'm going to go ahead and solve for c right now by plugging in the initial condition f of 0 equaling to 1, which means I'm going to plug in the value 0, 1 into here. So this is 0 for x, 1 for y. God, that's going to be annoying. Wait, yeah, is that the right points? Did I pick that point? Why did I pick that point? All right, let's pick that point and plug that in. So I'm going to have here 1 over 2. E to the 1 squared is equal to, goodness, lights, that scared the bejesus out of me. My lights just turned off. Is equal to 0 squared plus c, which means that this is going to equal to e over 2 is equal to c. right? So I'm going to plug that in for that point right there for c. You guys okay with that? E to the 1 is just e, right? Divided by 2, so this is e over 2, and that's 0 right there. So that's c is going to be equal to e over 2. So I'm going to go ahead and plug that into here. I'm going to go ahead and plug that into here. So I have here 1/2 e to the y squared is equal to x squared plus e over 2. Now, if this is a free response question, I kind of just like stopping there. I found out what my particular solution is, and I've done all the calculus work. If this is a multiple choice question and it's worded like this, where they ask you to find y equals, more than likely, you're going to have to get in the form that y is isolated by itself, right? So again, free response question, I'm lazy sometimes, and I'm lazy a lot of times. I prefer leaving my answers like this. I found out what the particular solution is. I found out what C is. I like leaving it there. If you want to find out what y is equal to, though, this is now going to be testing your algebra skills. Yeah, are you good at getting your y by itself? So the first thing I would do is get rid of the fractions here. I don't like having fractions here when I'm trying to get y by itself. So I multiply everything by 2. When I multiply everything by 2, I end up with e to the y squared is equal to 2x squared plus e. All right? Then, to get rid of this e over here, to get y down, if you guys remember this, if you learned about exponential equations, technique that you do is you take the natural log of both sides. So I would take the natural log of e to the y squared, and over the other side, I'm going to take the natural log of 2x squared plus e. When I do this, the natural log and the e function cancel each other out. I'm left with y squared is equal to the natural log of 2x squared plus e. And then take the square root of both sides and end up with y is equal to plus or minus. Now, this is the part that's a little fishy here. Plus or minus the square root of the natural log of 2x squared plus e. But here's the thing. My initial point was that f of 0 is equal to a positive 1. So yes, this is true. This function is supposed to be plus or minus, right? But when you graph the plus or minus, you're going to have one in the positive side and one in the negative side. And since my initial condition is the positive side, I only care about the positive part of this, and this would be my answer. And again, that's not the calculus part of this. This is the algebra part. So this part looks a little weird, but again, it's just testing your old algebra skills. How good is your ability to solve for a variable, right? And that would be it for that one. So when you deal with these e functions, you're more than likely, if you're solving for just y by itself, you're more than likely going to need to know that to get something down from there, you need to take the natural log of both sides. So when you take the natural log, it'll cancel out with your e function. Same can be said if you do the integral of something and you end up with ln of y and you need to get rid of the ln around it, you raise it to a power of e. So what that might look like is, this is a side note, this is a random problem. If you did some work and you end up getting ln of y is equal to, let's say, 3x plus 5. Let's say you did this and you got this right here. To solve for y, you would need to take both of these and raise them to the power of e. And when you do that, the e and the ln cancel out. You're left with y is equal to e to the 3x plus 5. Ta-da! And that's how you would get that. So just keep that in mind, right? That again, not calculus stuff. That's algebra stuff. Knowing the inverse of an exponential function and knowing the inverse of a natural log function. Does that answer your question for number 11? I'm hoping it does. I'm gonna zoom out right there so we can get all of this to fit in there. But I'm hoping that answers your question for number 11 on how to solve the differential equation, right? By separating your variables and integrating both sides. Again, I'm gonna pause here. At this point, if you have questions, this is where you should ask them. Ask me. Ask, and be saying, ask your neighbors if we were in class, but we're not in class, sadly. Did you guys hear the good news? Graduation got approved by the district. You guys have an option now. You can either do, you can still do the drive-through graduation that they did last year, or you can do the in-person ceremony, but they're only going to be giving out 3 tickets per family, and it's 2 sessions. Yeah, I don't know how much space they have. Yeah, so yeah, you're right. So for the 2 in-person sessions, one's going to be at 1 p.m. and the second one's going to be at 4 p.m. And I believe the number of seats, I could be wrong on this, is about 150 or 200. I think it's 150 though, but I could be wrong. But yeah, the seats will be spread out. I think they're not putting 6 feet between them. I think they're putting 8 feet between all the seats out on the field. And the seating in the thing will be like that as well. And then for the in-person graduation, if you want to make sure you sign up and graduate with your friends, they're making it so you can make a request on there for like one time or the other, and they'll try their best to put that on there. Won't that mean that not everyone can choose in-person grad? I think they have the numbers so that they just in case, like everyone wants to do in-person grad, that it should work out, Calvin. It should work out, I believe. Have they called the seniors, or how can they choose? They're going to be, I believe they're going to be sending out a message to the seniors soon about graduation, and also about, you guys are getting a mural in the parking lot this year that you guys will get the opportunity to go put your names on it, is what I've been told. But I believe that it is. They called your parents recently for our choice? Oh, okay. So it looks like they called. I think they're still calling, though. I don't think they're done yet. I don't think they're done yet, Jackie, because it's a lot of people they need to call. So I don't think they did it all in one go. Yeah, I don't think they did it all in one go. But yeah, keep an eye out. If you still haven't heard anything, then you can go ahead and ask your counselor about it. That's who I would message about. Let's see here. If I were to get C is equal to 2 ln of 3, would you like us to simplify? That's as simplified as that's going to get, Monica. If you really wanted to simplify it, I don't know if you guys see Monica's message in chat. If you get a C equals to 2 ln of 3, that's as simplified, I'd say, as it's going to get. But if you really want to simplify it, if you really, really want to, it's the same thing as the natural log of 3 squared. Because remember, the power for ln's, you can break that up, put that inside there. And if you really, really wanted to, you could write that as the ln of 9. If you really, really wanted to. Right? If you really, really wanted to. But I'm okay with this. You leave it like that, that's perfectly fine. Do you guys remember all your natural log properties, or all your log properties? The natural log of x to the a power is the same thing as a times the natural log of x. The natural log of x plus the natural log of y is equal to the natural log of x times y. And then, of course, the natural log of x minus the natural log of y is equal to the natural log of x divided by y. Random properties that you need to know from pre-calc. But again, I don't think it's that big of a deal, but there is a possibility that you might need to use something like that. Not on this test, not on my test, but on the AP exam, there's a possibility. But yeah, Monica, hopefully that answered your question. You don't have to simplify that, but you can if you want to. It's not something that's going to take off points if you do, unless you do it incorrectly. So don't simplify unless you really need to. That's like one of the big things I would tell you. Only simplify if you feel like you need to. Other than that, it's not worth it. It's not worth it, because if you get it wrong, they will dock a point, even though you got the work right. All right, next one up is 13A. This one's another slope field one. Do you guys really need me to do another slope field one? Because 13A is literally just those 9 points right there, from -1, 3, all the way down to -1, 1, and the rest of them. You just have to plug in your x and y values and graph those slopes. Can we do 13C? Yeah, let me go ahead and let me start up these polls again. I'm going to take off 13A. I feel like 13A and 12A were so similar. So let me start up this new poll. And what problem next? So again, putting the same options like 1, 2, 3, 4, 5, 6, 7. We skipped all those, right? Yeah, 7, 8, 9, and then we're jumping all the way down to we did 11, we did 12A, we didn't do, let's see here, 12B. Let's launch that one, and then the next one after that. What problem? Next. Again, I'm going to ask you just to pick one, even though there's 2 polls, pick one only, just to make it fair. 12B. I think we also have 12C that we didn't do, and 12D. So next one up is going to be 13A. We just said that you guys are okay with that, so I'm going to put 13B and 13C, and I'll launch that. So I'm going to give you guys a minute. Can you guys take a minute, go and vote on the new polls? Which problem would you like to see done before we get out of here? So, have a couple votes in the chat. We have 12B and 13C. Can you guys go ahead there and click on those options if you guys want those done? And I'll wrap up the poll in about a minute just to see where everyone's at. Whew. I'm so sleepy, guys and gals. Should have just gave you guys your test today. I think you guys were ready. You're not asking as many questions as I'm doing these problems. I think you guys would have been ready and you would have aced it. And then I could have slept while you guys took the test. Right? I could have just slept while you guys took it. All right, we got a vote for 5, a vote for 6, a lot of votes for 12B, and a lot of votes for 12C. I need one person to decide, be the tiebreaker for me. Am I doing 12B first, or am I doing 12C first? Is our test going to be open all weekend? Yes and no. It is going to be open all weekend, but as soon as you, for the juniors, you guys are taking the SBAC on Thursday, by the way. So you're not going to be in my class. So for you juniors, I need you to make sure your Chromebook works. You're going to be taking the math SBAC, and I really kind of want you to, make calc look a little bit better than it should. It doesn't actually matter. They don't really care what math you're in. You're going to be taking the same SBAC as every other junior. But in order to take the SBAC, you need to make sure you're on your Chromebook. You cannot take it on anything else. So if your Chromebook isn't working, you need to bring it in on campus and get yourself a loaner so you can take that test. And if you don't take the test, I promise you don't want to deal with the admin that's going to hunt you down and make you take that test. They are going to hunt you down, so just make sure you take it. No one's tie-breaking between 12B and 13C. I'm just going to go ahead and end the poll here. Oh, there we go. It went to 5 on that one. We're going to start off with 12B, and then I'll work down to 13C. So 12B, use the slope field differential equation to explain why the solution could not have the graph shown below. We can do this one quickly, and then I can go to 12C. So this one right here, you need to have your slope field drawn first, right? So for 12B, you need 12A done first. So if I have my 12 right here, drawn right here, here's the thing. Why can't this be the graph for this slope field? Can anybody tell me? Why would this not be a valid graph using the slope field? It looks like it hits this tangent line beautifully, this tangent line beautifully, and this tangent line beautifully. What tangent lines are they skipping through and just saying, screw it, I don't even want to follow them? And I hope you guys can see it. For this particular problem, I have a horizontal tangent line, it looks like. I'm pretty sure if I were to pick some more points along here, it kind of would graph and go this way instead, right? But yet, on this one, it just shows the parabola going all the way through. I don't actually know what the slope field looks like for your study guide for number 12. That's a lie. I have the answer over here. Let me take a look. Number 12, where are you? What do you look like? You look something like this? When you do the slope field for number 12, What do you know? Huh. It looks very similar to what I have. Yeah. So it's the same idea. Right? The graph of the function gets steeper as x moves away from 0. The slope field shows a flattening behavior. So this graph right here, if you look at it, it looks like it's getting steeper as it gets away from 0. But that's not the case here when we are looking at our slope fields. As it gets away from 0, it's supposed to get flatter right there. Instead, it just gets steeper and goes higher, right? And yeah, the other explanation is the one that you guys put in chat. It looks like there's a horizontal asymptote there, meaning that it shouldn't be climbing that high. It should kind of like flatten out at y equals to 1. So that would be it for 12b. I'm hoping that makes sense. You need to look at your slope field, and you should be able to imagine what your graph should look like, and you kind of just follow based off of the slopes that are there. Okay, so that's where that 12b comes from. Hopefully that makes sense. You just look at the lines that you draw from before, and you kind of have to follow those lines as a guideline. Like they kind of help guide you on your slope. So let me give you an example here. So if you're given a slope field, oh yeah, this will work. Let's go with something like this. Take off the solution, and then let me go ahead and screenshot this. Let's say I have a slope field that looks like this. This is a nice slope field. Put this over here. So let's say I have a slope field that looks something like this. Right, and they tell me that the point is going through somewhere right here, right? So if I were to follow the slope field, it looks like it should come out here, and then it curves up, and then it kind of flattens out, and it kind of follows like that. I should be able to see, like, what a graph is going to be looking like. So just based off these lines alone. So I know that when I'm given something like this, I know it doesn't look like this, because it defies these slope fields right here, these horizontal lines right there. You know what I mean? So you should be able to kind of estimate what the graph should look like. Now, it doesn't have to be perfect, right? You'll say, Nakmi, what if it has a point that's over here instead? Won't that graph look something like this? And I'll say, yeah, it will. And I'll take that as your answer. That's perfectly fine. But you should be able to look at these graphs and kind of like imagine, what is this graph looking like, right? Oh, it looks like this. Oh, it flattens out. Oh, it goes up here, and then it flattens out. Should look something like that then, right? Oh, this one up here is going like this. So it kind of comes up here, bumps like that, and then goes like that. So you just should be able to visualize what you think the graph should look like, what the original function should look like. Okay? It's kind of a neat thing to look at. But yeah, that's it for 12b. Let's go ahead and move on to the next closest one, which was 13c. Let's take a look at 13c. What's 13c look like? Whoops, zoom out a little bit. There we go. 13c. Find the particular solution of the differential equation here. Okay, so it's just like the other problem. It's just like all the other particular equations, all the other differential equations that we've been doing. Is there an issue in particular that you have with that one? Monica, since you were kind enough to type it out into the chat, was there something in there that you wanted to see? Was it this part where it says to find f of 0.2? Or was it just in general finding the solution? Oh, okay. So, all right. Hopefully you won't mind. Then I'm just going to do a different differential equation real quick just to find a quick one. And then I'll talk about what that f of 0.2 is asking you to do. So here, let's say 13 part C, right? It looks something like this here. Let's say I have here dy dx is equal to 2x over y, right? So again, to solve this out, I end up here with y dy is equal to 2x dx, where I integrate both sides, of course, right? Just like I've done earlier, right? That's all you have to do to solve these differential equations. You're finding y is equal to f of x. I'm going to go ahead and do this real quick. This is going to come out to be 1/2 y squared is equal to x squared plus c. Crud, I forgot to give myself a initial condition to you know what I mean? To solve that first part. So give me a second here. Let me calculate one out here. Oh, you know what? Let's go with there we go. Let's go with that. Let's go with why the heck not? Let's go with f of 0 equaling to 2 as our initial condition. Plug that in. We should get our values here. This is going to be 1/2 times 2 squared is equal to 0 squared plus c, right? With our initial condition there. This will give me 4 divided by 2, which is going to be 2, is equal to c. So I have my c initial condition here. This is going to be equal to 1/2 y squared is equal to x squared plus 2, right? Now, for part C on this worksheet that Monica is asking for, it says once you find your answer, they want us to find f of 0.2. That just means they want us to plug in 0.2 in for x to see what the value is. So I'm going to go ahead and work this all the way out. Solve it for y. So I have here, this will be y squared is equal to 2x squared plus 4. Square root both sides, I end up with y is equal to plus or minus the square root of 2x squared plus 4, which, by the way, I'm looking at only the positive side because that point is on the positive point of it. So my y function is going to be this one right here, only the positive value. So in order to find out what is f of 0.2, that's just telling me to plug in 0.2 for x. So I would go here. This would be 2 times 0.2 squared plus 4. And then I just have to evaluate that, Monica, and then whatever that comes out to be, that's going to be what f of 0.2 is. That's pretty much it. So this right here would be 2 times 0.4 plus 4, which would be 0.8 plus 4, which will then be the square root of 4.8. And that would be it for that one, Monica. Hopefully that answers your question for 13C. 13C, like again, it was just this differential equation. It's asking you to solve and find your differential equation and then plug in 0.2. Hopefully that helped. All right, I got a couple more minutes here. Let's take a look at the next problem here. Next one up was 12C. Well, what do you guys have to do with 12C? What's 12C looking like? It's another one of this one. So do you really need to see 12C? 12A gave you the sketch. 12C is very similar to 13C. You need to integrate both sides, get this plus C there, and then solve for the plus C by plugging in 0 for x and -1 for y. And that's all I'm going to pretty much say for that one, because I think you guys are going to you're getting the hang of it, right? I'm hoping. All right, if you want help starting this off, I would divide by y minus 1 squared to the other side. All right, you know what? I just realized you might need a tip for this one. X times y minus 1 squared. So when you're actually, you guys might need help separating this one. So like I said, that is the first point that you should be able to earn, right? And it is a little bit difficult on this one, but I'm hoping you see that y minus 1 squared is a term in itself, and I can just divide that whole term to the other side, and I can just multiply the dx over here. So I can rewrite this as dy is equal to x times y minus 1 squared dx, and then divide by that whole term that has the y in there to the other side. So I end up with dy over y minus 1 squared is equal to x dx. That's the first hint, or that's actually just me giving you the beginning part of that problem. The second part is when you integrate this, you're definitely going to need u substitution here. You're not going to be able to do this one without u substitution on this side. You're going to need to do u substitution on that one. And that's because the derivative of y is just dy, right? I'm hoping you guys can see that pattern, right? That this looks like a derivative of just that. So you can let u equal to the non-derivative part, and you'll be able to do that problem all the way through. Okay, so that's that one in a nutshell. Hopefully that answered your question for anyone who voted for 12C. The next one up are single votes for 5 and 6. Let's take a look at those real quick. What's 5 and 6 look like? Number 5 is a fun problem, and so is number 6. 5 is a u substitution problem. I'm just going to tell you that right now. You let u equal to 2x minus 7, rewrite this, and do that integral. 6, same thing. It's a u substitution problem. You need to figure out which one is the derivative of which. Derivative of cosecant is not seen here. Derivative of sine is seen here. I probably wouldn't let u equal to cosine because I have no way of canceling out that sine because it's inside the cosecant function. So I'd sub out the sine for number 6 right there, is how I would start that out. So whoever asked for number 5, try it using u substitution, right? Let u equal to that. And then number 6, same thing. You got to use that with u substitution. You got to let u equal to, I would say let u equal to sine in this case. So that those are number 5 and number 6 in a nutshell right there. And then I think that's it. I think one more is left is number 12D. What's 12D? Find the range of the solution found in part C. You got to find out what the function is. Then you got to find out what the range is. So you got a couple ways that you can find the range. Remember, the range is how high and how low a function goes. You can either graph it to see what the lowest part of that function is and what the highest part of it is. Or you can go based off of the critical points you could try to solve like you did in the before, but that's going to take a very long time to do. There's no real shortcut for this. Excuse me. Other than maybe following your slope fields. Your slope fields might actually help you to figure out, does it go any lower than where that initial condition is at 0, -1? And kind of looking at my slope field, on my slope field that I got, which was this one right here, doesn't look like it goes any lower. Right? Doesn't look like it goes any lower. It looks like it goes to the low point here and then kind of comes back up here and flattens out like so. So what do I find for this range right here? This is +1 up here. This is -1. The range for this problem, I don't know if it's the same range as your problem, but the range for this problem looks like it's going to -1 and it hits that point down here at -1 because it hits that tangent line right there. And then this tangent line, it doesn't look like it hits. It kind of just gets closer and closer to it. I'd say it reaches up to 1, but it doesn't include it. That's how I'd say for the ranges for that one. The range, again, is just the y values, right? What are the y values? If you had your graph and it looked like this, then this one, wherever this point is, the range would be, let's pretend this is -1 down here. The range for this one would be -1 all the way up to infinity because it goes up forever, right? That's all the range is. So make sure you are able to look at a function and you're able to identify what the range is. That's an older technique. That's not really a calculus thing to learn, but you do need to show that you know how to find it. Okay, so that's that one right there for number 12. Right, you just do that and you get those. And I think that's pretty much all of the ones that you have questions that were asked. Yeah, 5, 6, 12B, 12C, 12D, 13C. That's all on there. Okay, so I guess we can just do a quick rundown for the last 5 minutes or so. Finish off the study guide. You get a curve. Finish off the Delta Math assignment, you get a secondary curve. If you only do one of them, you'll get a curve either way, but if you do both of them, you'll get a higher curve. The Delta Math assignment, I'm just going to let you know right now, I kind of goofed. I'd say I goofed. There's a topic on here on the Unit 6 review. Oh, this just puts everyone on blast, but right here, definite integrals with substitution type 1. I'm just not going to go there. Let's just go and look at, let's go look at the actual problems here. So definite integrals, u substitution, type 1. I kind of messed up on this one. So for type 1, I didn't show this to you guys, but the idea is this. When you do u substitution, you can actually plug in the A and B values into your u substitution and recalculate your A and B values so you don't have to sub back. So let me show you what I mean. So in this particular case, let u equal to the inside function. In this case, it's equal to 1/2 x minus 1. And you solve for du, right? You get du over x is equal to 1/2 x, which means that dx is equal to 2 du, right? Now here's the thing. When we finish this integral and we do the actual integral, we would sub back what u was equal to. We would plug this back out for what u is. But for this problem, for the definite integral substitution type 1, we're not subbing back. They just want to have you write out the integral with the u substitution, which means then we don't actually keep the numbers here. Those numbers need to change based off of what you plugged in for u. So right here, the number is supposed to go from -10 to -8. But if I'm letting u equal to this, I'm going to change those values by plugging in the -10 in for x. So -10 right here, half of that is going to be -5 minus 1. That's where they get this -6 from down here. This -6 is them plugging in -10 into this equation. And this -5 up here is then plugging -8. So -8, half of that is -4. -4 minus 1 is -5. And that's how you're supposed to be doing this problem right here. So you find out that these values change from -10 to -6, and then that -8 turns to -5. And then when you do your u substitution, there should be a fraction or a number that comes out of the integral. In this case, it was 1/1/2, or in other words, 2. And that's all they're asking for this one. You don't actually have to do the integral. You actually don't need to know the antiderivative of it. You just need to know how those things get affected when you do u substitution. So that one's a little bit weird. That's all it is. So for this one right here, right? Okay. Write an equation that can be inferred involving the integral of the function f of u. That's interesting. So I'm going to let u equal to 4x minus 5. So when you plug in 0, I should get here -5. And the b value should be 4 times 4, which is 16 minus 5. So that should be 9 right there, equal to -4. What is that inferring? That this thing right here would equal to that. Oh, knock me. That's gonna be a bad assumption if you want to just figure that out. Is that gonna be -21? That can't be right. That can't be right. That is not right. It's supposed to be -16. Oh yeah, knock me. Hello? You're supposed to find the fraction when you do the u substitution, which is 1/4, and then multiply the 4 over. I'm sorry. But yeah, again, as you can see, a little weird. All right, so this is what I was supposed to infer, and I was like, okay. But instead of taking that 1/4 and multiplying it to the 4, I plugged the -1/4 into the u substitution, which doesn't make sense. That 1/4 is supposed to come out of the integral because that's what you get when you do the u substitution, and then you solve it for it. Anyways, that's that one right there. So that one's a little bit of a sticky problem. But I think you guys can figure that out. The second thing is, again, I'm sorry for putting you guys all on blast here. The type 2 one is the one that we're usually doing. And then the rest of them I think are okay. The rate in, rate out problem might be a little bit more troublesome for some of you. Oh, David, you already took a look at this problem. Let's take a look at David's problem here. What? Who's done this problem? A couple of you have. Okay. This one, Monica, I appreciate the attempts that you have on there. But yeah, that's a tough one. But yeah, that's all it is. It's just basically for your curve. So don't stress out too much on it. It's not going to actually be on your test, but it's good practice for you to get you ready for your AP test. That's why I have that one assigned. But man, that is an abomination of a problem. That is a tough one. Okay, other than that, chances for other things to help you with your grade. Let me bring this up before, because I won't see you all next week. So, I won't see you all this Thursday because juniors will be taking the test. So after you take this test, those two things will help you with the curve for this particular test. Immediately after that test, I'm going to put out an assignment on Khan Academy to help you with your grade, not just with your test score, just with your grade in general. So Khan Academy is going to be coming out there to help you with your grade. And that other review, CalcMedic, will be out there to help you with your review. And there's going to be a third one I want to give out there as well. But the problem is this can be overwhelming, and I don't want you to be overwhelmed by this. All these things are for extra credit to help you with your grade if you want to help boost your grade up, right? You do them all, it'll be great, but I'm just letting you know right now, it is a lot of work. Khan Academy is a lot of work just for watching videos and whatnot and then doing the problems on there. But that will be up there and allowed for you. The second thing that I'm going to be looking for extra credit is your CalcMedic stuff. I need to set due dates on there just to show you guys what to do. But you don't have to wait for me to do them, right? You can just go ahead and do that. Could we earn more than 100? We'll talk about that later, Monica. You're talking about on the test with the curve, right? Talk about that later. But you can earn extra points from other things for others category grades in my class. But yeah, so that's those two things. We got Khan Academy, we got CalcMedic, and then of course, one last thing would be the AP classroom stuff. I don't know if you guys have seen this, but they started posting review videos now for the entire thing. And if you guys want to go ahead and start watching those, I'll be recording to see who has watched those come on, man, those weekly reviews. I'll talk more about it later. But for right now, keep an eye out after the test. Keep an eye out on Khan Academy. I'll go ahead and assign which videos you should be watching for the next part to help you with the curve, or not to help you with the curve, to help you with your grades, and the Calcmedic as well. I'll start to assign what reviews we need to start doing to get you a better grade in the class. Okay, but yeah. Other than that, it is 10:36. If you have questions, let me know. I'm gonna just hang around for a little bit. You guys are free to go. I have office hours today from 1 to 2 if you want to stop by to ask any questions you couldn't get asked in class. And I also have in-class tutoring from 3 to 5, so you can stop by from 3 to 5. Just make sure you sign up before you show up, because I'm going to be looking for people who are on the sign-up list. Okay? Other than that, have a good rest of your day, everybody. Have a good rest of your week. Get studying and get ready for your test that you're going to have on Thursday, everybody. Other than that, have a good rest of your day. So long, farewell, and I'll see y'all later. Bye, everyone. Whew.